Hello everyone, welcome to this class. Let us go on kinematics and study about the motion of an object. So first question comes, what is your movement? What is the movement? So movement of a body is change in its location, in a simple word. If a body moves from A to B, we can say that there is a movement of this body from A to B. And movement, continuous movement over a time period is called the motion. So movement, you can take example like one book if you have kept on table in the morning, and in the evening when you came back it is already in the cupboard. So you can say that the book has moved from table to the cupboard. So there is a movement with this book involved. And over a period of time, if the movement is happening and you are observing it continuously, then that body is said to be in motion. A car is moving. Its location is changing continuously. Now it is at A, later on it has reached to B point, and it is continuously moving. So this we call it as motion, in a simple word. So study and movement and motion we will do in kinematics. As you might have studied earlier also in earlier class about the speed, where you say that the speed is defined as distance travel divided by the time taken in covering that distance. A body moved from here to here. A distance is d. Time taken t from here to here in covering this distance. So when you write distance by time, distance is d by t. So this is not the speed. You cannot exactly say that it is a speed. Rather it is said average speed. Over this distance. So why this average word has come? Because when the object is moving from A to B, what is happening in between this d distance, you never know. Maybe the object has speed up and then slow down and reach till d. So information of motion in between this A and B location is not available with you. What is available with you is the distance d and from the timer the time t. So with this, when we divide distance by time, it is called average speed. So average speed, you can think in another way. It will have a definite value, right? It will have a definite value. Maybe let us say, for sake of easy understanding, 5 meter per second. So average speed, you can say it is the constant speed of 5 meter per second with which this object moved from A to B, covering the distance d in t time. So average speed can be taken as constant speed. So when the or we should interpret it in a different way, average speed between the 2 points, the movement from one point to another point, can be taken as constant speed, and it can be said that that object has moved with that constant speed, which is average speed, from A to B point. But in between what is happening in covering this distance, this information is not available. As I said, it may have speed up in between and then slowed down, then again speed up and then slowed down, and that way it has reached to, it has covered a distance t. Now when we say instantaneous speed, another word, instantaneous speed, as the name itself suggests, that speed at a certain instant. How do you define the instant? What is the instant in time? You can simply understand in a simple word. Suppose your body started at 10 a.m. and I say that what is the speed at 10:15 a.m. If you have the information available at 10:15 a.m. that, let us say, it is going with 50 meter per second, the object is moving with 50 meter per second. So at this instant, 10:15 a.m., its speed was 50 meter per second. So this 50 meter per second is your instantaneous speed at 10:15 a.m. This should be very clear in your mind. In average speed, when you are taking distance and time, so time is having a significant value. It is not very small, it is macro. Macro like 1 second, 2 seconds, 30 seconds, hour. But when you are talking about instantaneous speed, means how to calculate the instantaneous speed, then you should have the way to measure the distance travel in a very, very, very small interval of time. Let us say that in small interval of time is infinitesimally small. So if I say infinitesimally small, it means in seconds, if you write infinitesimally small, 0, 0, 0, 0, 0, keep on going like this. Infinite time 0 and then maybe 1 second. So this is infinitesimally small time. So in this infinitesimally small time, you have the way to measure the length traveled by that object. Then you can divide that length divided by this time, this small time, you will get the instantaneous speed. Means at that instant. In notation, you can write like this: instantaneous speed of any object when we are writing. Delta L is the length, delta T is the time, limit delta T tending to 0. Means when delta T is almost 0, what is the length covered by that object during the motion? If that we have, we can say that instantaneous speed by dividing it. So dl, and we can further express it as dl by dt. So this is your instantaneous speed. This is your average speed. D by T you can also write like delta L by delta T, where delta L and delta T is having the finite value. Here delta T is infinitesimally small. Accordingly, you will have the delta L in instantaneous speed. Since speed, average or instantaneous, is distance by time, and distance is nothing but length by time. So its unit, its unit has been in international system D-unites, Systeme International D-unites, or SI system. SI is Standard International System. The length is measured in the terms of meters. And time is measured in second. So its unit in SI system will be meters per second. This meters in SI system is given in notation small m, and time t. Sorry, meter in m, and second is s. So it can be written like this also. You know that it Someone likes to write it like this, so this also is same, meter by second. Also written as meter per second like this. So what is this? S inverse 1 is 1 by S. These all are same. This, 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 this. So this unit is in SI system. In this question, it is shown that England's Mo Farah, winning his second gold medal at the Rio Olympics in 2016, he ran 10,000 meter in 27 minutes and 5.17 seconds. To calculate the average speed. Why this average speed word came? Why not speed? Instantaneous speed? Because you know, during the running in the race, the runner speed changes with depending on situations. Initially may be faster, in between slow to save the energy, and towards the end again fast enough to win the race. So speed is not same throughout. So that is why this word average speed has come. So it is saying you have the time and the distance run by this runner, Mo Farah. He ran distances 10,000 meter. Time is 27 minutes plus 5.17 second. To calculate the average speed, you need to bring this time in 1 unit, either second or minute. So better to go in minutes. So 27 into 60 second plus 5.17 second. So your time has become plus 5.17 second. Now you can calculate the average speed. Distance traveled d by t. D is 10,000 meter divided by time is 1625.17 second. If you calculate this, if you divide this and whatever value you get, so that will be meter per second average speed. See, length can be measured in kilometer, centimeter, millimeter, time also the same way, seconds, minutes, hour. So depending on which unit of measurement you are selecting, your unit of speed will change. Like length, if you are measuring in kilometer and time in hour, so your speed will come in kilometer per hour. If measuring in millimeter, the length you are measuring in millimeter and and time in second. So speed will be millimeter per second. But in SI unit it should be meter per second. So here is a question given. Here are some units of speed: meter per second, millimeter per second, kilometer per second, kilometer per hour. Which of these units would be appropriate when starting or when stating the speed of each of the following? So what are those things? A tortoise, a car on a long journey, light, a sprinter. So you know that tortoise moves very slow. Means higher the time, very small distance. So which should be appropriate? Millimeter is the smallest, not smallest, but millimeter is small than meter. So we can select the unit as length unit as millimeter and time as second. So for tortoise it will be millimeter per second. Car on a long journey. Long journey means where you are spending on car so many hours and you are going kilometers to kilometers. So kilometer per hour will be appropriate for car. Light, you know that the light speed is very high, 3 into 10 to the power 8 meter per second, if I am not wrong. It's very high. So we can further convert it into kilometer per second by dividing by 10 to the power 3. So it will become kilometer. So light can be measured in kilometer per second unit. A sprinter. Race is generally of 100 meters, 400 meters, like that for the sprinter. So it is in meter and the runner covers up it in seconds. So meter per second is appropriate for that. Meter per second is appropriate for D. So this is D, this is A, light is C, and this is D. But if someone, or like if you wish that no, I want to measure the speed of tortoise in kilometer per hour, you will not be wrong. Only thing what happens when you try to calculate in kilometer per hour, you will be getting the speed of the tortoise in fraction or in, so fraction, you know that you will have to divide one number by another number. So it will be a cumbersome job. It will not be easy. So it is better that it should be brought to the smaller unit and then calculate so that you get a whole number. Or even the fractional number, but easy to cut, easy to divide. A snail crawls 12 centimeters in 1 minute. So what is its average speed in millimeter per second? So you see, it is asking in millimeter per second. Distance traveled by snail is 12 centimeter. Time 1 minute. It takes 1 minute to travel a distance of 12 centimeter. is 60 second. It is asking in millimeter per second. If you convert it into millimeter, it multiply with tens, this much. So average speed of the snail will be 2 millimeter per second. If you would have measured in centimeter per second, so your distance was 12 centimeter, your time was 60 second, so your average speed in meter per second, in centimeter per second will be 12 by 60, 1 by 5. Now you will have to divide further. So it has come in fraction. If you want to convert it into meter per second, so D is 12 centimeter, that will be 12 by 100 meter. T is 60 second. So your average speed, the snail average speed has 12 by 100 into 60 meter per second. See how difficult now it is to cut. 10 to 5, so 1 by 500 meter per second. Then divide it and then get the fractional number. So it is a cumbersome job. So that is why the units, when you are dealing with, you should try to calculate it in that form of unit which is convenient for you to do the calculation. So this is just an example. In question it has been asked about this answer, millimeter per second. But I am trying to give you the example. If you take it in meter, further if you take it in kilometer, it will be further cumbersome. So in the previous question, where it is asked like which unit we should select for this A, B, C, D, so you have to look into this. You have to consider from those points. Like, okay, for tortoise it will be millimeter per second because tortoise moves very slowly. Car is going kilometers and in hours it is covering, so kilometer per hour is fine. Light is very high speed, so kilometer per second is fine. A sprinter covers the distance of meter in seconds, so meter per second is fine. But apart from all this, SI unit is meter per second. Determining speed. How do you determine the speed? A body moves from here to here. If you have a timer, when it starts and it stops, if you have the timer and you can measure the time, that in this much time from start to this, t is equal to 0 to t is equal to t. So total in t time, the body moved, and if you have the distance, the way of measuring the distance, that you know that if it is d distance, So you can easily get the average speed. If d is in meter and time is in seconds, so meter per second. When you are moving on a car on a highway, so you might have noticed that every 2 kilometer or 2000 meters there is an emergency telephone booth. So suppose something goes wrong with your car, so you can move to that place and can give a call for assistance. So it is at equal spacing, like okay, every 2 kilometer the booth is given. So when you are crossing one emergency booth, okay, emergency booth, phone booth, number 1, emergency phone booth, number 2, you are sitting in the car, moment you just start crossing this number 1 booth, you start your timer on. And when you reach here, exactly at this point, stop timer, clock. So you get the time between these two. And that time, if let us say is t, and the distance, you know that it is 2000 meter. Let us say it has taken 2 minutes, this timer, as per timer. So you can get the average speed very easily. Distance d by t, distance is 2000 meter, divided by 2 minutes is 2 into 60 second. So from here you will get the average speed. So this is the way of determining the speed or determining the speed. There are other methods as well to know the speed of the car or any body, in fact. Only thing, you should have the way to measure the time and the distance. If these two are available, you know the average speed. There is one question, like if your car is moving and you see the speedometer, so it is giving you some figure, maybe 50 km per hour, so 100 km per hour. So what is that speed? That speed is the instantaneous speed. Every instant it is giving the car speed, that it is moving at this speed at this instant. This is one of the live example. Same way for motorcycle, for a scooter. Now let us look into the methods of calculating the speed through practical. Two light gates method. This red color which you are seeing is the beam of light. This is your first gate. This is your second gate. This one. You have a trolley. Trolley, a card has been installed on it, and we know the length of the car is D. Let us say D. The beam of light, that is this red color, is coming from this equipment. The same way at the second station. And this instrument we call timer. How it works? When there is no obstruction to the beam means light beam, the light. The ray of light goes straight, and on this side you can say that there is photosensor, photocell. So it is falling on that and giving a signal to this instrument that there is no obstruction on the way of beam. This beam height has been taken in such a way so that it is higher than this height, the trolley height, this height, but lesser than this height. It is, so beam height is somewhere between these two. So when the trolley crosses this gate and the leading edge of the card, leading edge is this. The leading edge of the card obscure or obstruct this beam, just started obstructing, just came in the way. So at that time this photocell will stop sensing that any beam is coming here, because this card is opaque. This card is opaque, it is not allowing the beam to pass through. So this photocell, because of light not falling on it, the ray or the beam not falling on it, will trigger the timer to start. Your timer will start. Now when it comes, the leading edge comes in way of the second beam which is which is arranged on the second gate. Again here photocell, till the time it did not, so there was no obstruction, so light was comfortably falling on photocell and photocell was sensing that light beam is coming on it. But when the leading edge of this obstruct this ray from falling on your photosensor, this timer will stop. So this photocell gives the stop signal, and this photosensor gives the start signal. So in timer we have recorded now the start time and the stop time. Difference of these two will give you the time interval in which the D length of the card has crossed. So you have the distance D, so your average speed will become D let me correct. Start time you got, stop time you got, difference you got. So time interval is with you. This is your time interval. Through this timer you got. And if you know the distance between these two gates, if it is L, leading is passing or obstructing this first ray start, leading is obstructing the second ray, timer stop. So the distance moved by the leading edge is from here to here, that is L length. So distance is L. L is your distance. So you can get the average speed L by T. So this is the way you can calculate the speed of this trolley by experiment. So this is two light gates method. The important to know is from before you know the distance between the first gate and the second gate. That you know other things, the timer is giving you the time. That leading is start from here and reached here. So that time is T. So average speed you obtain. Based on that, this question is the distance between the two light gates is 20 centimeters. Means L is given 20 centimeter. The leading edge of a card installed on trolley passes the first gate at 10 am. Means 10 am your timer started. Triggered the start of the timer. The leading edge of the card breaks the second beam at 5 seconds past 10 am. Triggered the stop of the timer. So timer stopped now. So after how many seconds the timer stops? 5 seconds. So you got the T is equal to 5 seconds. So average speed of the trolley will be L by T, 20 by 4. This is centimeter second. So 4 centimeter per second. So this is the way the average speed is calculated following the method of two light gates. Now we will go to one light gate system, the second method. A single light gate to find the average speed of a trolley. Here the system is a bit different. When the card leading edge obstruct this beam, the timer start. When the card trailing edge, the aftermost edge, just cross it, the timer is stopped. So if you know the distance of or the length of the card L, and from start and stop you got the time T. So T is known, your L is known, so your average speed will be L by T. So this is single light method. or single light gate method, sorry. Only one gate, only one light beam. In two light gate method, there were two beams, two gates. Question based on single light gate system. A trolley with a 5 centimeter long card, means L is given, 5 centimeter, passes through a single light gate. The time recorded by a digital timer was 0.4 seconds. What was the average speed of the trolley in meter per second? So time also is given. So your average speed of trolley will be L by T. Your L is 5 centimeter, T is 0.4 second. So that you can write 5 into 10 divided by 4 centimeter per second. Twenty-five by 2 is 12.5 centimeter per second. So this will be the average speed of the trolley. And this calculation is based on the single light gate method, where you have the way to measure the time with the timer, and the card length you can measure by the tape. Third method is your ticker timer method. Ticker timer method. What is this ticker timer? Ticker timer is an instrument which works on the frequency of the electric supply. So generally in houses or any industry, the electric supply is having 50 hertz frequency. 50 hertz. Frequency. So what does this mean? 50 cycles are completed in per second. This is also called 50 cycles per second. In 1 second, the light is completing 50 cycles. So in how much time it will complete one cycle? 1 by 50 seconds in one cycle. In 50 cycles it is completing in 1 second. So one cycle it will complete in 1 by 50 seconds. So ticker timer instrument prints a dot on the tape every 0.02 second. So if we attach tape with the trolley, and the tape is also passing through the ticker timer printing machine, the trolley is moving in this direction, So your tape is also moving in this direction. Every 0.02 seconds, it will keep printing the dot. You can see 0 seconds dot here, 1 second dot, 0.02 seconds, second dot, again after another 0.02 seconds, third dot, and so on. You can see the spacing. 0 to 1 is lesser than 1 to 2, 1 to 2 is lesser than 2 to 3, 2 to 3 is lesser than 3 to 4, 3 to 4 is lesser than 4 to 5. The length, I am talking about the length. So what does it mean? Time between 0 to 1 is 0.02 seconds, 1 and 2 is 0.02 seconds, 2 and 3 is 0.02 seconds, 3 and 4 is 0.02 seconds, 4 is 0, between 4 and 5 0.02 seconds, but the length is changing, length is increasing. So your length is increasing but time is fixed, so it means your average speed is increasing throughout this process as per this ticker taper print. So when you run the trolley with different speed, for 0.7 seconds, you take the ticker tape out, measure the length between each print like 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, like that. Or since 0.02 seconds is too small, so if you take 5 dots together, so in 5 dots the time will be 0.02 into 5, so 0.1 second. And in that 0.1 second we measure the length and make a table like this: 0.1 second 2 centimeter, 0.2 second 5 centimeter, 0.3 6 centimeter, 0.4 10 centimeter, 0.5 15. We make a table like this and we plot it on a graph. This side, horizontal side second, let us say this x-axis, this axis is, this is y-axis. So on x-axis if we show seconds, the time, and on y-axis we show the distance in centimeter, and we plot from this table the points and draw the graph, we will get such kind of graph. So by ticker timer you can see that you have the information that what is happening between 0 to 0.1 second, 0.02 second. You can see that between 0 to 0.1 and between 0.02 the speed has increased. Between 0.2 to 0.3 speed has decreased. Again 0.3 to 4 increased. So this way you will get a information that in between what is happening. If we take a distance d, so in between what is happening at different interval of time. Is the speed same or is it changing? Is it increasing or decreasing? How much decreasing? How much increasing? So from this graph you can calculate. So where the speed is changing too much in an experiment or in of an object, so you can select this method to get maximum information that what is happening in between. This is your ticker timer. one of the question, suppose you will be given ticker timer, two ticker timer like this. Figure below shows two ticker tapes. Describe the motion of the trolleys that produce them. So what are you getting here? In A and B, in A, spacing is equal, you see. So it means here the speed was constant speed. Trolley was going in constant speed. As per this ticker tape, A ticker tape. But in B ticker tape, if you see, the gap is increasing. So it means in this case, the ticker tape what has been made, the speed is increasing the speed. Why? Because for the same time, 0.02 second, the length is changing and this length is increasing gradually. This length is increasing. So it is increasing speed. If it was decreasing, so it will be less space. So we can say, so such kind of question can come to you. They will give you some ticker tape image and ask what is happening between this to this time, between this to this time. So you have to basically check the length because the timing between the two dots is same. So only you have to focus on length. If the length is decreasing, speed is decreasing. If the length is increasing, speed is increasing. Why? Because the speed is length by time, distance by time. So length high, speed high. Length less, speed less. Another one is motion sensor. So what is the mechanism in this? You have an ultrasound generator. So it sends the pulse to the trolley that is installed with the card. So this ultrasound pulse moves with the sound, moves with the velocity, go and strikes with the card and trolley and comes back, reflects back. So this motion sensor records that time, that at this time the first pulse collided with this and then it came back, and this is so fast that gives a very precise time, very small time, that in this interval of time this much the location of the trolley was this, and in another time, another short interval of time, the location is different. So these two locations will be giving you the distance and time you already have here. So these all are fed in computer, which automatically computes the speed of the trolley. This ultrasound speed is very high. So going and coming back is very small time, very small interval of time. So you can say that it is one of the way to measure the instantaneous speed. Because the time interval will be very small, and during that time interval you are measuring the length, how much length or how much distance that trolley has covered. So these things which you are seeing is the ultrasound pulse. Ultrasound pulse. Wave. You may be asked to explain what is the best method of out of 4 to choose in an experiment. So you have to keep in mind these 3 points. What do you need in that motion to observe? What information you need in that information, in that motion? If the speed is changing continuously, you may think of that, okay, you should get a method, you should choose that method which gives in between information also. That is your ticket type method or ticket timer method or motion sensor method, because these two methods are giving the information in between also. What is happening in between? Whether speed is increasing, whether speed is less. How precisely does the method measures time to the nearest millisecond? Means measuring the time, if the error is less, better will be the result, more accurate will be the result. So is the method simple and convenient to set up in the laboratory? The method which you are choosing, is that method can be set up in the laboratory? So that also is important. So basically you should look into these 3 points, and basis that you select which method I should use in laboratory to measure the speed of an object in an experiment. One is easy to set up, whether you can set up easily. Second is whether you need the information in between. Third is the timer which you have, will the error be minimum in that, so that you can reach to a very close result. Or very accurate result, I should say rather. One question is, out of 4 methods, which 2 methods are suitable for studying the motion of a falling mass? So what is happening in the falling mass? Your speed is changing continuously. So if you select the method of ticker timer and motion sensor, then by this method you can get more accurate result, and knowing all the information, what is the speed at this location, this location, this location, more precise or more precise result at different locations. That okay, since the motion is changing continuously, so you can select these 2 methods, but you have to check the feasibility, whether this method can easily be set up in the practical room. If it can easily be set up, so these 2 methods will be the best methods for doing the analysis of falling mass. And the reason is very simple. The sticker timer and motion sensor is giving you the speed at different locations also. If you use the light gate method, the 2 light gate method or single light gate method, you will only get the average speed, distance by time, total time. But in between information Like what is happening in between, that information will not be available with you. So we will continue the kinematics again in the second part. For the time, we should call up the class here. Thank you.